All right, so I'm going to go over the homework first. I did break down most of my work so that you would kind of be able to see some of what I did. So I have the equilibrium expression set up right here. And then you can see I first figured out what my numerator was, and then I figured out what my denominator is right down here. And then I went ahead and plugged them into my calculator. You should have gotten 1.25. We do only want to have two significant figures because each of our concentrations here have two significant figures, so I'm going to round that to 1.3. Okay. Next problem is right here. Again, my work is shown. We're going to have 0.005 squared divided by our concentrations of our two reactants. Don't forget this gets taken to the third power. Should have gotten 20. We do want to have two significant figures, so I should technically put a decimal right there to make that 0 significant. Finally, on number 3 on this page, I did break down all of my work so that you can kind of see. I first went ahead and took 2.05 and I squared it, and I got this right here for the numerator. Then I took all of my denominator, solved for that, and I got 1.43 times 10 to the negative 7th. So I broke it down so that way you can see in case you put something wrong into your calculator. And then finally you end up with 29,400 and something. I went ahead and put it into scientific notation, and I went ahead and reduced to the proper number of sig figs. So 2.9 times 10 to the negative 5th power. All right, so on number 4, you can see I've got my setup ready to go. And then I first solve for my numerator here, and then the denominator here. So you should be taking 6.8 times 10 to the negative 8th and dividing it by 1.4 times 10 to the negative 8th. Your answer for number 4 then should be 4.86. Again, we want 3 significant figures. If we look at the concentrations of each of them, there are 3 significant figures there, so 4.86 will have the correct number of sig figs. On number 5, I've got my setup. First I solve for my numerator, so 0.025 to the third power times 0.025 is going to get this number up here, and then 0.01 to the second power is going to get this number right here. I then solve, and you should get 0.0039. We do want 2 significant digits. If you put it in scientific notation, it would be 3.9 times 10 to the negative 3rd power. All right, on the back side, number 6, I have everything set up here. We're solving for something a little bit different. So my K is 0.89, and we're solving for the concentration of this guy right up here. So I've got him as my X, and I solve for my denominator down here, and I get 12. So basically when it comes down to it, you end up with let's change the color there, 0.89 is equal to x over 12. And if we want to solve for our x there, what we would do algebraically is we'd multiply each side by 12. That cancels out the 12 here and leaves us with just x, and that means that we get 10.68 as our moles per liter, our molarity concentration of that material. But we've got to put it in the right number of sig figs. So if I look at this number, I've got 2 sig figs and I've got 2 sig figs, so my answer needs to have 2 sig figs. So 10.68 would round up to 11. So 11 molarity is your correct concentration. All right, number 8. On the back side, you can see my setup all here. 2.04 is going to be equal to an unknown concentration for my carbon dioxide times the concentration of my hydrogen gas product divided by the concentrations of my reactants. Now, once you've got that set up, I first have it set to solving for my x, and I find out what my denominator is. So I went ahead and I multiplied those two numbers in the denominator. Now, this whole thing here is, this whole thing right here is set equal to 2.04. So, algebra, if I want to solve for my x right here, my first step is to get rid of this denominator down here. So I'm going to multiply this side by this number, which means I'm also going to multiply 2.04 times this number. That is going to leave me with this being equal to a number. Then I'm going to divide each side by this number right here. And when I do all of that, my x, my concentration of my carbon dioxide is what I'm trying to solve for. And the concentration of that carbon dioxide should come out to 3.09 times 10 to the negative second moles per liter. So that's what you should have gotten for an answer for number 8. Now, finally, we want to know whether the products or the reactants are favored for these last three. So you should have gotten the reactants favored for A, products favored for B, and products favored for C. So that should be it. Real quick, I apologize, we did not do B, so you don't have to worry about that one. All right, so finally let's talk about what you're going to be working on today. What you need to do is you need to work on making your note card that you're going to be able to use on tomorrow's quiz. What are some of the things you should put on there? Well, you should put how to calculate K. So you might want to make yourself a note things like the products are on top and the reactants on the bottom. Maybe you want to give yourself some examples. Don't take up too much space because this card is the card that you are going to be using on your final exam. So we're going to add more stuff to it on Monday. So keep it limited because you're going to have to add things from all the beginning of the semester, things like stoichiometry, moles, calculating solution concentrations, parts per million, like all those kinds of things. So you'll want to be able to put on there how to calculate K, and then you'll want to put on there the equilibrium shifts. So which way does something shift if you add product or if you add reactant? So you want to put all of those on there as well. So I'm going to give this card back to you. You have to turn it in after you're done putting what you want on it. You're going to get it back tomorrow at the quiz, and you'll get to use it on the quiz, and then we're going to add to that card on Monday in order to start prepping that card for the final exam. So that's the first thing you're doing, is you're working on this card, putting some information on there, keeping it small enough because it's the same card you're using on the final exam. Finally, once you've done that, you're going to turn that card in. It needs to be in my hands. I have to have it tomorrow. You can't walk in with a card. The card has to be the card that has my handwriting in red with your name on it on the top. Once you're done with that, you can work on your homework, which is an Edpuzzle, which is reviewing what we've been doing for helping you prepare for tomorrow's quiz. I will see you tomorrow.